Hello and welcome to Nostalgic Ramble. We are busy with May IEB Paper 2, May 2024 IEB Paper 2. Question 4b. In the diagram below, F, E, A, and B, F, E, A, and B are points on the circle with center O. So there are a whole lot of radii for us to work with here. Angle at center, isosceles triangles. Okay, maybe not angle at center because we don't really have angles at the circumference. We just have the angles at the center, so maybe that's not very useful. But we do have a whole lot of isosceles triangles, so that's nice. Right, CD is a tangent to the circle at B. Tangent, Tan-rad. If we only have one tangent, so we can't talk about equal tangents, that theorem. Tan chord, maybe. We don't have any angles at the circumference though, so yeah, maybe not tan chord, but definitely Tan-rad. Right. ABC is 38 degrees. Right. Determine A. So I immediately see that Tan-rad relationship, which can give me B1. And then because this is an isosceles triangle, we know that these would be equal. So that's my strategy. So we know that angle B1 plus, or rather, let me say angle OBC is 90 degrees. And that's because of the tangent CD being perpendicular to the radius OB. Wow, okay, that bracket did not compute. Right, and so therefore angle B1 is going to be 90 degrees minus 38 degrees, which is 52 degrees, right? So just going to scribble that on there. And then we know that OB is equal to OA because they are both radii, right? And so therefore triangle OAB is isosceles, right? And so then angle A is equal to angle B1 because base angles, well, I think the more official reason now is angles opposite equal sides, right? And so therefore it is equal to 52 degrees, which I will also just go ahead and scribble over there. Right, forward we go. Okay, next question says if EF is equal to AB, determine O1. If EF is equal to AB, determine O1. Right? So, I mean, we know that equal chords subtend equal angles at the circumference, right? So, for example, if both of these chords subtended an angle at the circumference, then these would be equal. And that would mean that O3 is 2 dots and O1 is also 2 dots. So by extension, equal chords not only subtend equal angles at the circumference, but they also then subtend equal angles at the center. I don't know if that's an official theorem, but at the very least it's an extension of the equal chords theorem. So if we can find the size of O3, then we will have determined the size of O1 as well. I guess another way that we can argue this is these are the same length. They're all radii, so they're all the same length. And if this is also equal, then these triangles are congruent. Maybe that's actually the better way to argue it. They're congruent by the reason side, side, side. So yeah, actually I'm just gonna stick with arguing it that way. I don't think it would be wrong to argue it the first way, but anyway, it's just more labor, right? So so we would say in triangles OFE and OAB, we know that OF is equal to OA because they're both radii. We know that, so that's OF and OA. We know that OE is equal to OB, also because of radii. So OE is equal to OB because radii stuff. And then finally, EF, which is this guy, is equal to AB, which we were given. Right, and so therefore we can conclude that triangle OFE is congruent to triangle OAB, and the reason is side, side, side. And let's just check that I've got my order right. So OF is equal to OA, FE is equal to AB, OE is equal to OB. Right, yes. And so therefore, what do I want to say? Therefore, angle O1 is equal to angle O3, right? Because we're saying, I'll just color code this. O, F goes with A, E goes with B, right? So those two are equal, those two are equal, those two are equal, right? This is just me reading from my statement here. So yeah, this first statement is me just saying those two are the same. And I can work out the size of O3. Well, and this is because, sorry, I'm jumping all over the place here. This is because these two triangles are congruent. And O3 is equal to 180 minus angle A plus B1. The reason for that being angles in triangle OAB, the sum of those angles, and that is 180 minus 52 plus 52, and that works out to, you know, needing some shrinking. Okay, that works out to be 180 minus 104 is 76 degrees. And so both of these guys are 76. Right, and I think that's it for that question. So let's have a look at the memo. Question 4b. So they do indeed start with Tan-rad to help us work out B1, and then we work out A is equal to 52 using the isosceles triangle. And then for the second question, they just leap right into saying, oh, they work out O3 is equal to, so they work out O3 using the interior angles of triangle OAB, and they work that out to be 76. And then they say O1 is equal to 76 because equal chords subtend equal angles. So I'm guessing then the theorem doesn't speak specifically to subtending angles at the circumference. It's just subtending angles anywhere. So I guess subtending it to the center as well is covered by the theorem. So actually, I would have saved myself a lot of writing if I had known that. But anyway, we arrived. We all arrived. Oxalive. Okay, anyway, thank you so much for coming along for this ride, and I hope to catch you in another video.